everyone. I am Aditi Kinkhabwala from New LJ Institute of Engineering and Technology. Let us continue with the topic of queue, which is part of Unit 2, that is linear data structure. So students, in this lecture, we would be going through what is priority queue and what is the array representation of priority queue. Now students, we have already gone through the simple, that is linear queue and the circular queue. Now students, if you remember, in linear queue as well as in circular queue, there was one condition that deletion was always going to be from the front side, right? So the front was responsible for the deletion, and wherever the front is pointing, we had to delete that data. Now, in priority queue, again, it is one kind of data structure related to queue, but it is somewhat different in the sense that in priority queue, each element is assigned a priority. So based on that priority, it will be decided that when that particular element is removed from the queue in order to make further processing. So in order to have further processing, which elements need to be related will be decided on the basis of priority. So the priority of element will be used to determine the order in which the element will be processed, right? So it does not depend just on front. Okay, based on the priority, it will now be decided that which element, how the element is inserted and how the element will be deleted. So basically we can say that a priority queue is nothing but a modified version of queue, in which when element has to be removed from the queue, the one with the highest priority is retrieved first. So it will be decided that which number will be getting highest, which element will be getting highest priority, and that particular element will be deleted or retrieved first, right? So it is basically element will be removed based on priority in the priority queue. Now students, one of the important application of priority queue is it is basically in operating system. Now for example, in order to have, if there are multiple processes and there are different priorities of the processes, that what needs to be executed first, right? Now in order to execute a high priority process, the priority, for example, one way to decide priority is, for example, CPU time, right? So priority of the process may be set based on CPU time. There could be other factors as well. Now if operating system is running 3 processes, first process needs 5 nanosecond, second process needs 4 nanosecond, and third process needs 7 nanosecond. Now if the base deciding factor is CPU time, so based on CPU time, we can see that 4 nanosecond is the shortest. It takes less amount of time. So definitely it will be having higher priority and it will be the first to get executed. So it's not the one which is first entered. No, it is the first which has the highest priority. Now, different characteristics of priority are, first is that in priority queue, every element has some priority associated with it. So an element with higher priority will be deleted before the deletion of less priority. So deleted in sense it will be executed. So once it moved out of the queue, it will be executed with respect to operating system, right? So we have just seen this example. Now students, if two elements in the priority queue have same priority, in that they will be arranged in first out principle. So first element will be deleted, the one which is having higher priority, and in case both of them has the same priority, it will be arranged using first come first serve, that is first in first out manner. Now, by default, there are two types of priority queue, which is ascending priority queue and descending priority queue. Basically, in this, elements are in already sorted order, right? So, ascending priority queue, what happens here is, ascending means starting from 1 to n, right? So, it starts from the lowest number. So, if it is a ascending priority queue, the lower priority number. So the lower the number is, the higher it has the priority. So when the situation comes to delete an element, who has the highest priority? The one which has the lowest number. That is the situation in ascending priority queue. So as you can see here, this is in sorted order. So 2 is the lowest number, that is, it is having the highest priority. And when it has to get deleted from any element, has to get deleted from the queue, it has to be 2, because it is ascending priority queue, where the lower the number, higher the priority. And in this situation, 11 is the element with the lowest priority. Now reverse is the situation with descending priority queue. Now in descending priority queue, as you can see, this array is so queue is implemented in form of an array, and it is a descending array. Here, higher the priority number, so the if the number is higher, the priority is also higher. So as you can see here, element 10 is the element with the highest priority, so it will be first deleted or retrieved from the queue. Implementation of queue. Now, while coding or while implementing queue, we can use the concept of arrays and linked list. Also heap data structure, which we would be seeing in nonlinear data structure, right? So heap data structure is also used in order to implement priority queue. And there are two basic operations on priority queue, which are insertion and deletion. So today we would be looking at implementation of priority queue, that is insertion and deletion operation with respect to arrays. So how array representation is done of priority queue, that we will see first. So two operations we are concerned with, that is insertion and deletion. So when arrays are used to implement priority queue, a separate queue for each priority number is maintained, right? So if there are 1, 2, 3, 4, and 5 priority numbers, so separate queue would be maintained, and each of these queue would be implemented using circular arrays and circular queue. So students, the concept would be implemented using circular array and circular queue. That means the queue will be having front and rear pointer, right? So each queue, if there are this 5 queues, each would be having front and rear. Okay, so each would be having its front and rear, and based on priority, elements will be inserted and deleted. Now, for a priority queue, we use two-dimensional array where each queue will be allocated same amount of space. So if you see 1, 2, 3, 4, 5, so each queue has total 5 spaces. So here we can say n is equal to 5. Okay, so this is the two-dimensional representation of priority queue. Given the front and rear value of each queue, two-dimensional matrix can be formed, right? So this is front and this is rear. Now what this means is, see students, element A is having priority 1. These are priorities, right? So element A is having priority 1, element B, C, and D is having priority 2, E, F is having priority 3. This is a certain situation at certain point of time. This could be different also. I, G, and H are having priority 4. Now students, now if we see, there is just one single element A over here. So for this queue, for this first priority 1, what would be the F and R, front and rear? So definitely that would be at A only, because there is only one element, and that is at the third location. So this is the third indexing. So front and rear, both of them are at 3. Okay. So again, let me repeat it, that this could be any situation. So we are just considering any random situation in priority queue. Now, if you see B, C, and D, so they are at priority 2. Okay, so they are at priority 2, and indexing is 1, 2, and 3. So where rear would be pointing to the last. Okay, so now if something gets inserted with priority 2, it will be getting inserted over here. And where is the front? Front would be over here, because currently nothing is deleted. So front is 1 and rear is 3. Next, again, one more time, what is EF? So rear would be over here and front would be over here at the first element. So front is 4 and rear is 5. Similarly, I, then there are two spaces, G and H. Now see students, this is a circular queue. So what is the next element to get deleted? So next element to get deleted is F. So here it is front pointer. So insertion, insertion, and insertion. This is the rear pointer. So if we want to insert one more element, rear pointer will increment, right? So front of K and rear of K. Okay, what is K? 1, 2, 3, 4. We can say it is a row also, as well as it is the priority number, right? So now let us try to insert one element. We have one element and we have its priority. So where it will be inserted, in which queue? Let us see that. So in order to insert a new element, so for example, new element is R and the priority is 3, add the element at the rear end of the row K. Okay, so there are 1, 2, 3, 4 rows. We can say there are 4 queues where K is row number as well as priority number. So if you have to insert element R with priority 3, where we will insert? So first of all, priority is 3. So we have to insert R with priority number 3. So what is the old position, students? So see here, the old position is this. So at priority, we have to insert R and priority is 3. That means it will be inserted somewhere over here. Now currently this is F and this is R. Now if this is a circular queue, what is R plus 1? It will point towards R is equal to 1 here, right? So now this is the next pointer. And here what will happen? Here R will be inserted, right? So can you see here? R is inserted over here. Now, when R is inserted over here, what is rear pointer pointing to? 1. So instead of this 5, now it will be pointing to 1. Right? So priority queue also, if priority is given, so it could be in ascending, it could be in descending, and if priority is given, we can also have it with respect to 2 arrays and 1 2-dimensional arrays. And here the priority also indicates the row. Students, let us look at what is the deletion procedure. So in order to delete the element, we require a non-empty queue, and then in that non-empty queue, what is the front pointer pointing to? Now we have arranged this in such a way that priorities are already assigned. So whatever is there in the first priority will be the one which is getting deleted because 1 is having the highest priority, right? So in our priority queue, first non-empty queue. So this is the first non-empty queue. Okay, this is the first non-empty queue and the priority number is 1. And what is the first front pointer pointing there? It is pointing at 3. So the first element will be deleted is A and it will be processed first. Okay, so we have to ultimately what we are seeing this, we are finding element with the smallest priority, right? So number is K is smallest and it is having the highest priority. So whatever is there at front of K, right? First element, right? So we have to find the first element where it is currently not equal to null and we have to delete that particular element. So this was all about the topic priority queue. Thank you.